My name is Kavita Kansara. I am the Employer and Academic Engagement Manager at Engineering New Zealand. First of all, thank you very much for coming along tonight. Thank you to all students. I know you've all had a tough day today, so thanks for coming. Thanks for all industry for joining us as well. Before we start, and in the interest of health and safety, I'm going to first ask David Wareham to explain the health and safety evacuation procedures.
Yes, good evening there. For that person that just came in, I can let you sit down in the front as long as we don't have anybody sitting on the aisles, but you need to be having a seat, obviously, for health and safety. So if you'd like to come down the front, there's a place down here beside that you can sit. That's great. All right, so just very quickly then, you should know the rules here. In any case, in the event of a fire, just evacuate through the nearest exit. If there's an earthquake, then drop, cover, hold until the shaking has stopped, and then exit out here. And of course, there's a quadrangle out there that you could gather, okay? And so move clear away from the buildings. But that's a very unlikely event, but we just need to brief it down there. Thanks. Okay.
Thank you. I'll just hold on to it. Right. So, first of all, I just want to talk a little bit about student membership before we start. How many of you students here are engineering student members at the moment? Okay, so for those of you that aren't engineering student members at the moment, I strongly encourage you to become a member. First of all, it's free, okay? It'll take you less than 2 minutes to join up. But why should you join up? Okay, there's hundreds of things that you can join up that are free. Why should you join up for this? Well, first of all, if you're looking to get your practical work hours at some point, it's all about who you know. So we can give you the opportunity to engage and meet people. We can also give you the opportunity to improve your soft skills and your confidence. If you're a wee bit shy and you're not quite sure what to say to people when you meet them, come along to our events, and that way you can practice your communication skills. So if you want to sign up, it'll take you a couple of minutes. All you just need to do is sign up once, and so all the time that you're actually studying, you will just continue to be an Engineering New Zealand member. I will introduce Katie from the branch shortly, and she'll tell you a little bit about what the branch actually do, because the branch here in Canterbury are one of the most active branches in the country, and a lot of stuff is happening at your doorstep, so you can come along. So first of all, you're probably thinking, coming along to something to do with Engineering New Zealand, should I go to that? I'm actually studying chemical engineering, or I'm studying forestry. We encourage all students studying, regardless of discipline, to become a member. Also, if you're doing a 2-year diploma at ARA, or the 3-year BEng Tech, or you're doing the 4-year BE here, the Masters or a PhD in engineering, you're all eligible to become student members. And it's free, okay? Another thing, this is an amazing opportunity to network. How many of you guys actually made business cards and brought them along tonight? So what I would really encourage you to do, when you come along to any events, when you go along to the career fairs, when you go along to different things, make yourself some little business cards. Go onto Google, look up free business cards, and get some made. And the reason I say this is students never ring themselves. They never remember their phone numbers. I's, L's, number 7s, and 1s all look the same when you write them. So make up a little business card with your name, the discipline that you're studying, what you're doing, and your email address, and so when you actually see people, you can hand them out to them. Okay, that's one of my suggestions that I make. So here's a good opportunity for you to actually go along to some of the branch events and meet other engineers in industry. So I'm going to now ask Katie from the branch to come here and just tell you a little bit about the stuff that the branch does. And don't be shy, because the branch love listening to what students are doing, okay?
Thanks, Kavita. Hi, everyone. I'm Katie. I'm a committee member at the branch. So I'm just going to reiterate what Kavita said. So we run lots of events throughout the year, very active, very busy for us. So our events range from site visits, networking opportunities, and presentations. So we really like students to show up to these events and meet with peers and network, job opportunities, and all that. So that's it, really. Thanks, Kavita.
And what I would also say is that a lot of our members, you'll come and see members in the branch, things that you're doing now, they didn't do when they were studying, so they're really interested in learning what you're actually doing. So come along and say hello. I also want to say joining Engineering New Zealand is an opportunity to meet engineers in industry and senior engineers, and I just would like you to meet a few of our senior engineers. So I'm going to start off with Craig Price, who is our immediate past president, and he'll talk to you a little bit, and then Andrew and Sina will have a little chat.
Thanks, Kavita. Great to be here tonight. And I must admit, there's not that many engineering events I go to where there's people turned away at the door almost, so fantastic to see such a great turnout. So as Kavita said, my name's Craig Price, immediate past president of Engineering New Zealand, very passionate supporter of the profession and particularly the education side of the profession as well. I was sitting where you all are about 30 odd years ago. I graduated from University of Canterbury in 1986-87 with a mechanical degree, Bachelor of Engineering. So it's fabulous to be back. I've kept a fairly close association with the university over the years, serve on a couple of advisory boards, so have a good understanding of what's going on. I started my association with IPENS, as it was then, as a graduate engineer, and have maintained that throughout my working career, taken on various roles from competence practice area assessor to serving on the competence assessment board, and more recently on the governing board, and last year as president. And it's really given me a chance to engage in the profession in a whole lot of different ways. One way that's probably of interest to you as soon-to-be graduates, I'm involved in the International Engineering Alliance and the Standards and Accreditation Board, and I've just recently spent 6 days in London at meetings of the International Engineering Alliance, which governs the Washington Accord, the Dublin Accord and the Sydney Accord. So one of the great things about an engineering qualification, of course, is its mobility, and it's these international agreements that enable that mobility. So it's important that Engineering New Zealand are supported and are able to negotiate mobility agreements on behalf of all our engineers. Anyway, that's enough from me. I'll hand over to another past president of Engineering New Zealand, Andrew Reid. Andrew.
I don't know why we have the smallest microphone in the house, but that's what we have. So I'm Andrew Reid. I'm an electrical engineer based here in Christchurch. Can I ask you, please, first, who are the civil engineers in the room? Put your hand up, please. Structural, if you differentiate those from civil. Mechanical. Electrical. Congratulations. Chemical, if I said that. And any others that I haven't named? So what I have just done is divided you into a whole lot of little groups around your discipline. What Engineering New Zealand does, it brings you all together under one banner of professional engineers. So you all are professional engineers, or you will be, and that's the thing that unites you all together. Your disciplines put you into little technical baskets, but the profession of engineering is what brings us all together. So that's the thing that's kept me going through my career. I am an electrical engineer, I do electrical engineering, but I've been given a great opportunity through Engineering New Zealand and through some international organisations to look at the profession of engineering. And that's what Helen Davidson's going to talk to you about tonight. So can I congratulate you on choosing the engineering profession, that you haven't chosen to be a lawyer or an accountant or whatever else it may be. No, seriously, as a lawyer, a New Zealand lawyer, you can work in London. I think you can maybe work in Hong Kong, and that's about it. As an engineer trained in New Zealand, you can work in any country in the world. So if you want to travel, you can. You go to a country where they don't speak English, they'll learn English so they can communicate with you. So being an engineer is a truly global opportunity for you. So well done, congratulations. Sina, would you like to come?
Tēnā koutou, everybody. My name is Sina Korotate and I'm the newest member of the Governing Board. So I was appointed in March. I'm a civil engineer by trade. I trained here at Canterbury as well many, many years ago, got my BE here, and in fact I'm still around the traps as a student, so you may see me around from time to time. What I'm happy about with tonight's presentation with Helen talking to you guys about ethics is it's probably the most important part of our job, no matter what discipline you are or what kind of work you do. Ethics and judgment is probably the toughest and also the most important part of our work. I'll tell you a wee story about when I was 8. My parents were having a discussion after work. They both had a long, hard day at work. And my mum is a theatre nurse. She works in a hospital in an operating theatre. And she said to my dad, who's an electrical engineer, she said, "Oh, you sit in your office all day. Who cares if your reports are late? If I stuff up in my job, somebody could die." And my dad said, because he does power stations, said, "My dear, if I stuff up my job, hundreds could die." So I don't mean to be down, Buzz, that's quite an extreme example, but it illustrates the fact that the work that we do affects everybody around us. It has an impact on our communities, and that's why it's so important that we think about the way that we do it and how we do it, and in fact what we do. So when I talk to my fellow engineers about how they find meaning in their work and why they enjoy what they do, they usually tell me they like to make the world a better place. And whether that's cleaner or safer or, funner or greener, however you do it, it's about leaving the world a better place. And I think that really ties in nicely to this concept of ethics. So I'll hand over to Helen. Thank you very much.
Let's try and get this right. Sorry, obviously I'm not very good at this. I'll make a confession, I'm a lawyer. But Andrew and I are good friends, so that's all right. There we go. Okay, sorry about that. Thanks for bearing with me. So, welcome. What a great room full of people. I'm Helen Davidson. I am the General Manager for Legal and Policy at Engineering New Zealand. You might be asking yourselves why a lawyer has come to talk to you about ethics and professionalism. So what I'll do is I'll just tell you a little bit about myself and how I got here. So I studied law at the University of Otago and quite quickly realised that I had an interest in professional regulation and professional ethics. After I finished my degree, I went on and did a master's in bioethics and health law. I've worked in health law, patient safety and ethics for most of my career until making the switch to engineering about 2.5 years ago, and I've also done quite a bit of spent a bit of time in academia doing research in ethics, but in the biotechnology area, so the ethics of pre-implantation genetic diagnosis, embryonic stem cell research, biobanking, and looking at how the interface between regulation and ethics in those respects. So that brings me here today. At Engineering New Zealand, within the legal and policy team, we are responsible for policy, obviously, and in-house legal advice, but another important function that we carry out is complaints management, so helping resolve complaints about engineers, about our members, and about chartered professional engineers. And what we see through those complaints allows us to identify opportunities for learning around ethics and professionalism. So I'll also be bringing that in to the talk today. I don't see a clicker around, so I actually am going to stand here and manually do this. So I wanted to start by asking you, have a point of reflection, asking you to think about what ethics means to you. So just have a little bit of a think about that. What does ethics mean to you? Is it about doing the right thing or acting in the right way? Any nods? It's always hard to get a big group of people to warm up, so I'll forgive, but hopefully by the end you'll be right into it with my rhetorical questions. So is it about how we decide what's right and wrong and what act or decisions we should make? So I want to tell you a story. A tiny bit of it might be true. It's Saturday night. I'm at home on the couch, maybe watching the latest season of Suits. I am a lawyer, enjoy that sort of thing. There's a knock at my door. So I go to the door and I open it, and there's my friend Lucy. Now, I've known Lucy since I was a child. My father was a doctor, and he actually delivered Lucy as a baby. So that's how long I have known her. She's breathless, and she's obviously been running. She says, "Helen, I'm being chased by an ex-murderer who wants to kill me. Can you please hide me?" Now, being the nice friend that I am, I say, "Of course, Lucy. Go upstairs. You can hide in the bedroom wardrobe." So Lucy runs upstairs to hide, and I close the door and lock it and sit back down to watch TV. But about 2 minutes later, there's a knock at the door, and it's a man wielding a large axe. And he says, "Hello, I'm an ex-murderer. I'm looking for Lucy. I'm intending to kill her. Do you happen to know where she is?" So what do? Do I tell the ex-murderer that Lucy's upstairs hiding in my wardrobe? Or do I protect Lucy and tell the ex-murderer that I haven't seen her? So some ethical theorists would say that when making decisions, we should be guided by rules, such as don't lie, it's never okay to lie. Some of you might have heard of a philosopher called Immanuel Kant, and this was his view, that we should only act in accordance with and for the sake of obligation. So tradition, conscience, emotion, sympathy, all of that stuff should not be part of the decision. So it's never all right to lie, even to protect people. So in taking this approach, I would tell the ex-murderer that Lucy is upstairs hiding, because that's the truth. On the other hand, some people say that we should make decisions that have the best overall consequences. Some of you know this as utilitarianism. So the right thing to do is the action that produces the best overall result. The best result would be for me to protect Lucy and for her not to be murdered. So I should decide not to tell the ex-murderer who wants to kill her that she's hiding upstairs. Trouble is, if you dig a bit deeper, if it's consequences that are important, is it the consequences of the particular action or the consequences of applying a certain rule? For example, euthanasia. We may think that the right thing to do for our friend who is suffering a terminal illness is to allow her to choose to die. So that would produce the best result for her. And it's the best consequence in this particular case. But what if this were a rule? Would it work? Would it have the best overall consequence for society if we were to make this a rule? That if terminally ill people should be able to choose to die, where would we draw the line? Would this leave the most vulnerable people in our society unprotected? And that's one of the issues that's at the heart of the euthanasia debate. So I've talked about two of the most common theories to approach ethics and ethical decision making. There are many others. There's virtue-based, there's liberal individualism, there's communitarianism, or the ethics of care. What I'm trying to illustrate here is that ethics is a complicated subject area. There's a lot of research and theory dedicated to what it is and how we should make ethical decisions, how we work out what is the best thing to do in a particular case. And the takeaway message is that there are many ways of looking at these things, and ethics is not black and white. So what you need to know entering the workforce is how to identify a practical or ethical dilemma, and how you can make the best possible decisions about how to respond to that dilemma. So that's what I'm hoping that I'll be able to help you with today. We're going to start with another problem, because these are fun. Have any of you watched the show The Good Place? Yay, a few, okay. So if you have, some of you might recall Ted Danson, who's the actor. I can't remember his name in the show, but he talks about the trolley problem. And this is a classical way to explain an ethical dilemma. And it goes something like this. There's a runaway trolley barreling down the railway tracks. Ahead on the tracks, there are 5 people tied up and unable to move, and the trolley is headed straight for them. You are standing some distance off in the train yard next to a lever. If you pull the lever, the trolley will switch to a different set of tracks. However, you notice that there's one person tied up on the side track. So you have 2 options. You can do nothing and the trolley kills the 5 people on the main track, or you can pull the lever, diverting the trolley onto the side track where it will only kill 1 person. What is the most ethical choice? Pull the lever? A few nods? Yeah?
Are there consequences to your actions, like if you pull the lever, you might be charged with murder because you decide to kill someone?
So that might be something you want to weigh into your decision making. What would be the implications of one decision over the other? Not just who's going to be harmed, but what's it going to mean for you? Do you think, what if the one person on the sidetrack is a child? Maybe it's your niece or your nephew. For those of you that were inclined to pull the lever to kill one person, does that change your point of view now that you know that it's someone you love? It's interesting, isn't it? I'm not going to tell you the answer because there are no right answers. So I wonder if you're thinking that this is really interesting, but what does this have to do with engineering and you becoming an engineering professional? And why am I here today and what does this have to do with you? So the short answer is, and as Sina and Angie talked about, ethical practice is at the core of engineering. I'm going to talk about 2 key reasons why. So first, as an engineer, you belong to a profession that holds significant knowledge and expertise in your hands. You are capable of making judgments, applying your skills, and reaching informed decisions in situations that the general public can't because they haven't attained the necessary knowledge and skills. Furthermore, the decisions that you make and the services you provide don't just impact you and your client, but have wide-ranging impacts on the public. So, excuse me, think about your relationship with other professionals in your life, a lawyer, maybe a doctor or a nurse. It goes without saying that we expect those professionals to act ethically and professionally. We rely on them, and we wouldn't be questioning why I'd be standing here in front of medical students talking to them about medical ethics. But think about this, and it's similar to the point that Sina made. An electrical engineer or a water engineer can kill more people from one mistake than a medical professional might. So just like with medical professionals and lawyers, the public places significant trust in engineers to self-regulate. And with this trust comes a great responsibility. As a professional, you return this by being a member of a professional body and committing to be competent and professional in your work and to act ethically. The second reason why you need to know about, why I'm going to tell you that you need to know about this today, is because you will, in the course of your career, encounter many ethical and practical dilemmas. Sometimes the decisions you need to make are simple, but there will be times when you feel pulled in 2 different directions, and how you respond might not be immediately clear. When this happens, when you have competing obligations, you need to be able to identify it's happening so that you can work out the best way to respond. So I've made 2 key points so far. Ethical practice is important, and ethical decision making is not black and white. There's a lot of grey around it. So this might leave you with the question, how does a professional know how to act ethically? So professions commonly produce codes of ethics that contain guidance to the issues that typically arise in the area of practice. And these embed certain fundamental moral norms that are hard to argue against. In engineering, the Engineering New Zealand Code of Ethical Conduct sets out shared expectations that engineers aspire to and have agreed to uphold. So drafted by engineers for engineers, the code is a means by which the profession has set out certain principles, values and responsibilities that help guide ethical and professional behaviour. And these principles remind us of our obligations and responsibilities to others and the need to consistently demonstrate high standards of professional behaviour. The Code of Ethical Conduct is designed to help you with difficult decisions. Ethical principles don't always provide precise or specific guidance or answers for every conceivable set of circumstances, but the general principles help guide conduct. When you're faced with a difficult decision, use the code to understand what your profession has declared as the right thing to do, and use those principles to guide you through a decision-making process with reference to those standards of behaviour. Your goal is to use your judgment to make the best decision in the circumstances using these tools that are available to you. So I'm going to talk to you about what the code says, and we're going to talk about some case examples that will help get you thinking about how to apply it. But I also want to talk first a little bit about the theory of decision making. So, have you ever paused to think about how you actually make decisions in your day-to-day life? I want you to think about a decision that you've made recently. It could be anything from whether you should give some money to the SPCA people who are collecting outside your lecture theatre, right through to you've caught a classmate cheating on an assignment and you have to decide whether to report it or not. Okay. I want you to reflect, once you've decided or thought about a decision you had to make, I want you to reflect on how you decided what to do. Did you follow your gut instinct, or did you go through a rationalisation or reasoning process to decide what to do? And if you did, what were the factors that were important to you? Did some of those factors weigh more heavily than others? And why might some have had more weight than others? Were there any standards or guidelines that help, or legal requirements that help guide your decision? Did you think about what the impact might be on yourself and others? Did you think about what others might do in the same situation? Just keep that in your mind as we go through. When thinking about how we should make decisions and challenging and difficult ethical situations, it's important to have an awareness of how we make decisions and the ways in which we make decisions, and the ways in which we do make decisions can actually prevent us from making the best decisions that we can. So, humans predictably use two different systems when making decisions. The human mind is a serial information processor. We cope with information overload by processing that information in an automatic mode as a default as much as we can. And we generally only process information in a systematic way when we absolutely have to. So in decision science, this is often referred to as System 1 and System 2 thinking. System 1 is where we use rules of thumbs to make decisions, and we rely on our unconscious defaults. So in this mode, we make fast decisions. It's effortless and associative. We might use our gut more. System 2 thinking is more systematic thought. It's learnt, it's controlled, it's rules-based and slow and takes a lot of effort. So a good way to think about this is when you're learning to drive, you're using System 2. You practice, you're concentrating, you work through the different options. Okay, I'm going to turn, so I need to signal now. I need to make sure there are no cars coming. I need to put the brakes on. I need to change down. Oh, I look, my rear vision mirror. And you do all that before you turn. But once you practice and get more experience, you start to do it automatically. So you move into System 1 thinking. We actually spend most of our time in System 1 thinking, making very quick automatic decisions, and most of the time this is fine, it works really well for us. But we run into trouble when we use a System 1 process for making decisions when we should be using a System 2. And when we do this, we often depart from standards of accuracy and rationality in our decision making. Biases and errors influence our decisions in a negative way. Why I'm telling you this is because when you're faced with difficult decisions in your working life or at university, in your personal life, I would like to encourage you to move into a systems 2 thinking. So when you're approaching ethical decision making, you should be sitting within the system 2 thinking. Avoid making those snap automatic decisions and stop and pause and think to yourself, okay, I see what's going on here. I need to use a different type of decision making in this situation. Otherwise, we can fall victim to biases and errors and not make the best decisions that we need to make. Okay, and if we do system 1 thinking when we should be doing system 2 thinking, we can miss really important factors that are right in front of us. And I want to show you just a little brief video clip that illustrates that. Okay.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's gold below stairs, sir.
I was planting my petunias in the potting shed. Constable, arrest Lady Smythe. But how would you know, madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away. It's just a matter of observation. The real question is, how observant were you?
Tried to pause this. Did anyone notice anything? No, I've kind of given it away now that I've let the video go on. But did any of you notice anything in that video as you were watching it? What did you pick up on? Yeah, yeah. Anyone else notice some things? Yep. Carpet and flowers. Yep. Yeah. I'd just like to say I played this to our leadership team this morning and you guys are doing so much better. Okay, so watch this. Oh.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's gold below stairs, sir.
But I was planting my petunias in the potting shed. Constable, arrest Lady Smythe.
It's quite interesting, isn't it? The things that you miss when you're not looking for them. And so that's what that video is really to demonstrate, that if we're not concentrating, we can miss a whole lot of things that are going on right in front of us. And that was actually a road safety video for the UK, which is quite interesting. Slideshow. There we go. Okay, so a little tool I want to teach you when you're facing this type of decision is to ask yourself, is what I see all there is? And there's a little acronym for that, and it's YCRD. So is YCRD, is what you see all there is? So that's an important thing to stop and pause and ask yourself when you're facing a difficult decision. Okay, so making a good decision when you're faced with an ethical dilemma means being more of a system 2 thinker, weighing up all relevant information, considering your ethical obligations, and thinking about any implications or consequences of the options open to you, and staying objective. There are tools that you can use to help you get through this. For example, you can use a self-assessment model where you ask yourself, do I feel comfortable with this issue or situation? Do I have all the information? What are my options? What are the consequences and implications of those options? Who will benefit and who could be harmed? Is what I'm doing consistent with the Code of Ethical Conduct and the law? How would my peers respond if they were in the same situation? How comfortable would I be describing my actions to a respected senior engineer? Or how would I feel if what I'm this situation is reported in the news or the media. So it's about using that kind of self-assessment process to prompt you to make the right decision. And don't just ask yourselves, talk to your colleagues. You've got an amazing resource around you in your profession, and consulting with colleagues is a great way to test your proposed response to a difficult situation. And you can also talk to the team at Engineering New Zealand, so we're available to help you work through anything that you face. When you make a decision, keep a record of what you decided and why, including who you consulted. And this will be a good reference for you to come back to if you ever need to explain the decision that you made. Okay, so let's get on to what the code actually says. The code is built around, as I said before, some widely defensible moral norms, such as do not harm, be honest, confidentiality. So those are things that are principles of behaviour that most people would be able to say, yep, I agree, that's a fundamental principle that should guide how a professional acts. It's centred around 8 core obligations that are grouped into 2. So we've got obligations that are in the public interest and obligations relating to personal conduct. So with regard to obligations in the public interest, there are 3 core obligations here. You must, in the course of your engineering activities, take reasonable steps to safeguard the health and safety of people. So that's that do not harm principle. In the course of your engineering activities, you must have regard to reasonably foreseeable effects on the environment from those activities and the need for sustainable management of the environment. And you must report adverse consequences. I'm going to talk a little bit more about the reporting adverse consequences one. What the code says is that if you have reasonable grounds to believe that an engineering matter has or could have adverse consequences, you must report it. So your first thing you have to decide is whether you have reasonable grounds for believing that something will have adverse consequences. And that requires you to make that kind of assessment and do the kind of decision making that I've just been talking about for the last few minutes. So using your System 2 thinking. If following this process you think a matter meets that threshold, then there's a process that you need to follow in reporting it. And the first thing you need to do is talk to the individual concerned and try to resolve the concerns directly with them. And the issue might be resolved there, and you can sleep at night again. But if after talking to the person you're not satisfied that the matter has been appropriately dealt with, then you need to talk to the relevant regulatory body. So this is in recognition of your overriding obligation to protect the public and act in the public interest. Consider this. You're a graduate engineer working in a small firm. You're asked to prepare a design for a new structure. The firm have done something similar before, and they provide you with that design as a template. When you work through the design, you notice that there are some errors in the calculations associated with the work the firm previously did. You think that the errors in the calculations create fundamental flaws in the design that affect its strength and capacity and could put the public safety at risk. So what do you do? What are your primary obligations? Do you want to have a quick chat to the person next to you about what you might do in that situation? I'm going to interrupt you now It's, it's interesting when you do this on a Monday or a Friday, you always wonder whether people are talking about the case or about what they did at the weekend or what they're going to be doing. But because it's Wednesday, I think that there must have been some really amazing discussion on this case example. So does anyone want to share what they think the primary obligations might be or what they might do in this situation? Way up the back. So have a chat with someone at the firm about the previous design. Sorry, I had trouble hearing you. Yes. Yes, yeah. So report your concerns to somebody about the building that has already been built and make sure the new one doesn't repeat those errors. Yeah. Yeah.
Does this have anything to do with the CPD building? I'm sorry for bringing it up, but it just seems like...
No, these are just fictional case examples that I've brought up that have been developed. Yeah. Get someone to check your work, it might be wrong. Yeah, definitely. Good idea to check what you think first before you start taking drastic action. Not that reporting it would be drastic action. But so what if you do talk to the senior engineer in the firm and they say, oh, don't worry about it. The structure's already been built and it seems sturdy. No one's been hurt so far. So you shouldn't go causing trouble. The firm's reputation will be put at risk. Where do you think your obligations lie then? Yep. It's hard to do though, isn't it, when you're a graduate engineer in a firm to take that extra step? It's not easy, is it? Like I said, I'm not here to tell you what the answer is. But it's important to think about these things, and if you are in that situation, think them through, talk to people, share ideas with your colleagues, or call us at Engineering New Zealand and we'll try and help you with it. Okay, now I'm going to talk about obligations relating to personal conduct. So how you conduct yourself personally as an engineering professional will have a significant impact on your success as an engineer and also the public's overall view of the profession. So the code says that your obligations are to act competently, behave appropriately, inform others of consequences of not following advice, maintain confidentiality, and to report breaches of the code. So five key ones there. I'm not going to go through them all in detail, but there's some specific ones that I want to highlight. So the first one is about acting competently. This means ensuring your relevant knowledge and skills are up to date. So during continuing professional development, if you're a member of Engineering New Zealand, you'll be required to do 40 hours of CPD, continuing professional development, a year. If you're a chartered professional engineer, you also need to keep up to date through CPD. It also means only undertaking engineering activities that are within your competence and undertaking those activities in a careful and competent manner. So consider this. You are a newly qualified engineer. You've just started your first job working in the water industry. A friend of yours who is a real estate agent contacts you and asks you to provide a report on a retaining wall at a house they're selling so that they can show potential purchasers that it's robust. You studied retaining walls a bit in the course of your degree, but you've never practically applied your knowledge. You're working in water now. What should you do? Should you accept this work? Few shaking heads. What if you are 10 years into your career and you did some work in retaining walls in your first 2 years of practice and you did a one-day course on retaining walls about 4 years ago? Does that make a difference? Maybe. Yeah. So it might be a question of degrees. Where do you draw the line? My tip would be to put yourself in their shoes, do that old test. What would you want if you were the client? What level of competence would you want the engineer assessing the retaining wall on the property you're about to buy to have? What would you feel comfortable with? Okay, the second obligation relating to personal conduct that I want to take you through is behaving appropriately. So this means acting with honesty, objectivity and integrity, treating people with respect and courtesy, and disclosing and appropriately managing conflicts of interest. So as I said, one of the roles of my team is to consider complaints about engineers, and we consider complaints alleging breaches of the Code of Ethical Conduct by engineers. So this is based on a real example. We had a case where a structural engineering firm was recommending a specific technique for repairing foundations, and a person from a different profession had concerns about that technique and started sending emails to the firm questioning their recommendation for its use. And the emails were quite persistent. One of the senior engineers engaging in this correspondence with the other professional effectively lost his cool, as we all might in the particular situation. And in the email, he called the other professional irresponsible, a menace, who effectively needed to be knocked off his perch, among other things. And the engineer told that other person to just go away. So that person complained to Engineering New Zealand about the engineer's professionalism. How you act, how you communicate is really important. Even in situations like this, you need to keep your cool and you need to remember your overriding obligation to act professionally. It'll save you time and energy in the long run. We were obliged to look into this, and it cost the engineer energy, stress and money. And we ultimately found that the tone of the engineer's correspondence was not professional, and he made some judgmental errors. Although the case was dismissed, the engineer apologised to the other person. So it took time, it took energy, it took this engineer away from their business, it reflected on the profession poorly. It's so much easier if you don't have to deal with this type of complaint in the first instance. Behaving appropriately also means not offering or promising to give any person anything intended to improperly influence a decision relating to your engineering activities. It also means not accepting from any person anything intended to improperly influence you, like a bribe, or to otherwise engage in or support corrupt practices. Some of you may have read the publicly reported case of chartered professional engineer Stephen Bourlaise in the media last year. So Mr Bourlaise was found guilty in the High Court on 8 charges of corruption and bribery of a public official in relation to roading contracts, and he's been imprisoned. We investigated and found that he'd also breached his obligations as a chartered professional engineer and Engineering New Zealand member, and his status as a chartered professional engineer and member has been stripped. These types of behaviours can have really serious consequences for an engineer and for your career. So the third aspect in terms of the obligations relating to personal conduct that I wanted to talk about is maintaining confidentiality. So this one's pretty clear. Essentially, if you obtain confidential information from your client or employers in the course of your engineering activities, you mustn't use it for any other purpose other than the reason that it was given to you. And you mustn't disclose the information unless certain exceptions apply. So there are some exceptions to that obligation. You can disclose if you're required to disclose it by other obligations in the code. For example, your obligation to report adverse consequences overrides the obligation of confidentiality. Sometimes a law will require you to disclose information despite your ethical obligation. You can also disclose it if it's publicly available information anyway, or if the person who you owe confidentiality to gives you permission to disclose it. Okay, so we're going to work through some practical case examples now to get you to think about how you might apply some of what we've talked about. I'm going to play a video, so it's an animated case study that comes from our ethics webinar. So Engineering New Zealand has a free ethics webinar. If you're a member, it's in your member portal. If you're not a member, it's available at a small cost. So I'm going to use 2 of the animations from it tonight, and if you want to see more, go to your member portal or become a member and you'll have access to it.
contractor had agreed to use 2 per panel, as this was considered safer. When she points this out to the contractor, he assures her it is perfectly safe to use only 1 prop. He says he has worked many jobs like this. He also says that they are already behind schedule. To shut down work to add extra props would take time and be expensive. Engineer A doesn't have a lot of experience in this area. What should Engineer A do?
Okay, so do you want to have a chat to the person next to you again about what you think Engineer A should do? What does the Code of Ethics say? How might they work through a decision?
Susan told him what a fantastic job you're doing. Oh, yes. I see all the pictures from the back.
Is it going all right?
Yeah.
We've got to 7:30, right?
Yeah.
Yeah, okay.
And I was wondering whether you wanted to do a thank you to Canterbury University Forest students. Do you want to do that? That's the last thing we just did. Canterbury University Forest.
Hard to get here.
I'll come up. I'll come up.
Okay, so who thinks that Engineer A should overhaul the contractor and close the site immediately? Yep, a couple of people. Yeah. When you were having that discussion, did you think about, does Engineer A definitely know the changes to the design could result in injury and whether she should maybe get more information first? Or do you think the overriding obligation is like, close the site and then do your checks? Okay, so did anyone think that she should contact her senior engineer with photos and details of her safety concerns and ask for support to determine what to do, or something along those lines? Okay, a lot of people thought that. Yeah, that's a good one. What were some of the things that influenced you to choose that option? Yeah.
She was a representative, so she should contact whoever she's representing and ask them if they're happy with it.
Okay, so.
Yeah. Because she's not in charge. She's just company.
Yeah. Okay, so for those of you who couldn't hear, the response was that she's a representative, so she should contact the person she's representing and seek their guidance on it. Anyone else? Yep.
It also mentioned she didn't really have much experience, so that's probably a good reason to actually acquire some knowledge.
Yeah, so she doesn't, the scenario said she doesn't have much knowledge, so check in with someone who has a bit more knowledge to help her. Yeah. Anything else from anyone? Anything different? Yep. Yep, so check that she's got up-to-date details and that nothing's changed. Good, yeah. Okay, those are all really good things. So, doing nothing could result in harm to people. Shutting the site immediately when she doesn't have experience, to be sure, could lead to increased costs and delays for the client. So it's about weighing all that up, thinking about all these things we talked about and deciding what she or you think is the best decision in the circumstance. Okay, let's try another one.
Engineer A and Engineer B are partners in ABC Engineering Company. They've enjoyed a positive working relationship. Recently, Engineer A has noticed a significant change in engineering prompt. Engineer A has smelled alcohol on Engineer B's breath from time to time. Engineer A is starting to question Engineer B's competence, especially in matters of safety and design. She's worried that his drinking is the cause of his problems at work. Engineer A raises her concerns with Engineer B, offering him her support. Engineer B assures her that there are no issues and that he will improve his behaviour and quality of work. Unfortunately, there is no change. What should Engineer A do?
Okay, so I understand about 90% of you are students in the room today. So I'm going to ask to tweak this slightly before you have your discussion with the person beside you to make it particularly relevant to you starting out in your career. So same idea, but instead of business partners, it's you and a friend starting out as graduate engineers at the same firm. You start noticing that your friend is coming to work seeming quite confused, intoxicated, you're smelling alcohol. You talk to them and they assure you that nothing's wrong, but you start noticing them making mistakes that could put people's safety at risk. And you feel a lot of loyalty to your friend, they helped you with some difficult assignments at university. So the question for you is, should you say something to your manager? So again, do you want to have a chat maybe to the person on the other side of you, just to shift things up? Okay, I'm going to throw another spanner into the discussion because I like doing that. Would it change your view if during university your friend had found you cheating and had not reported on them? Would that matter to you, to how you respond now? Do you think that history is relevant? I'll let you have a wee chat again about that. Okay, that sounds like some really good discussion there. How many of you talked about some of the principles of the Code of Ethical Conduct as you were talking through what you might do in this situation? Did you reference back to that? Yep. Which one did you think might be relevant? Behave appropriately. Yep. Maintaining confidentiality. Yep. So, yep. Report breaches by other engineers. Okay. So what did you think you would do? How would you go about handling that situation? Does anyone want to share? Yep. Yeah, so that's an excellent option. So the response was you could talk to your manager or an HR person within your firm, and that way there'd be a two-prong approach. So making sure your friend is competent, is safe to practice, but also making sure that they are hopefully getting some support that they need to work through that situation. So that's really good. Anyone have anything different? Yep. Yep, so the response was that there might be other people in your friend's life, their friends and family, who you might know well enough to share your concerns with them and see if there's anything going on there or anything they can do to support them. Yeah. Okay. Did it change your view that when I threw in the spanner that your friend hadn't reported on you at university? Or are the stakes higher in the workforce when they're making mistakes that could affect the public? So, you're getting tired, aren't you? Yeah, it's been a really long day, I know. I won't keep you too much longer. Okay, so what happens if someone disagrees with my decision on an ethical matter or my behaviour generally? So if someone has concerns about your professionalism or conduct or about a decision you've made, they may complain. Most complaints arise out of communication issues. So what we see in Engineering New Zealand is there may be a technical issue going on, but it's usually miscommunication or a lack of professionalism when working through the issue that gives rise to a formal complaint itself. People might complain directly to you, or they might complain to a manager or an external body like us, like your professional body. So it's scary, isn't it? The idea that someone might complain about something that you've done or a decision that you've made. You know, I get that it can definitely be stressful when someone complains about your work. You know, I certainly feel this in my work when an appeal is made against one of our complaint decisions that we've spent a long time on trying to get it right, or when someone complains to the Privacy Commissioner about a decision that I have made on their request to us for information. But as a professional, complaints are inevitable. And there are many take-home messages for you tonight, but a key one is that there's nothing wrong with receiving a complaint. You work in a profession in which human error, mistakes and miscommunications are just part of the course. We're all human, and the chances are that you will receive at least one complaint during your professional career. It's not something to be ashamed of, and it's not something to keep to yourself. So we need to talk about this as a profession, and in medicine we talk about having an open culture, a culture that's open to complaints and open to learning. The engineering profession is also more visible and under more scrutiny than ever before. And I talked earlier about the fact that you're trusted with special areas of knowledge and skills, and to keep people safe. And that high level of expectation also makes complaints a more inevitable part of your professional life. And there's actually a high value in complaints. So they're scary, but they play a really important role. As an individual and as a profession, they help us learn and they help us make better decisions in the future. They help us identify gaps in services and to clear up misunderstandings. And they have a key role in helping us to improve as a profession and in building public trust and confidence in the profession. So how do complaints help protect the public? Well, in the health context, it's been well noted that the consumer's voice for bringing change is a powerful one, and that's no different in engineering. And it might be difficult to always see this, so I'll fully acknowledge that some complaints feel like a nuisance or insignificant or a waste of time. But think about this. In the UK, consumers spoke out about the poor standard of care that they were receiving at a hospital called Mid Staffordshire. Each complaint on their own seemed like a really low level, and people weren't sure whether to raise them or not. So a bedpan wasn't being emptied, a nurse was not responding to a call bell, staff were being rude. But taken together, these complaints demonstrated a huge systemic failing at that hospital, which was the subject of a commissioning of inquiry and resulted in wide-ranging patient safety and quality improvement initiatives and commitments across the whole of the NHS in the UK. So together, those consumers were a really powerful voice, and that voice resulted in really positive change. I was talking about this example at Mid Staffordshire Hospital at a complaints presentation up north just last week, and one of the engineers was nodding along. And afterwards he came up to me and told me that his friend had died at Mid Staffordshire Hospital. His friend went into hospital with a really minor complaint and never left. So this is really real. What we do affects people's lives. Recognising that complaints are an inevitable part of professional life and that they play an important role in a self-regulating profession will help you respond in an effective and professional way if and when they do arise. And how you respond is really important. So it can make a huge difference to the impact on you and on your business, on the person who is complaining, and on the credibility of the profession as a whole. So I want you to just think about a time when you were upset or disappointed with a service that you received from a professional. It could be a lawyer overcharged you, or a medical professional misdiagnosed you, or a loved one. Think about why you were dissatisfied and what it was about the service that really concerned you. And what did you do? Did you complain? And if you did, why? What was your goal? Were you looking for an apology or an improvement in services? Did you really just want someone to be held accountable and to understand that you had been harmed and affected by how they treated you? And how did what happened influence your view of that person and about the profession as a whole and their business? Did that one experience make you feel a bit negative about all the people within that profession or the service or their business, or not want to use that service again? So I'm not going to ask you to share, but I am going to ask you to keep that in mind as we go through the final parts of tonight's presentation. Complaints in itself is a whole presentation. I'm just going to touch on a few things here to sort of tie up the end of the ethical decision making. But I want to give you some quick tips on how you can avoid a complaint escalating. And the best thing is if you can recognise that a client is becoming dissatisfied and address their concerns before a matter escalates. So how might you do that? How might you recognise that someone's becoming dissatisfied? Any thoughts? Tone of voice, yep. Choice of vocabulary. It's a nice way of putting it. Yeah. Body language. Yeah. Angry emails, absolutely. So change in frequency of communication. Either they withdraw, communicate less, or it becomes really intense and persistent. Okay, maybe the person starts asking a lot more questions. What's the key one? Any of our engineers in the room?
Stop paying the bills.
Stop paying the bills, yeah. Yeah. That's a key one. The person asks for another engineer to get involved, or they want to escalate the communication, so they start asking to speak to your manager. Okay. So what do you think you should do if that happens? Do you think you should just ignore the person and hope that it goes away? It never goes away. Don't do that. What we do know is there is no one right way to respond to a person who's becoming dissatisfied. So different people have different needs. So you need to think about how you should respond to the particular person and situation. Any ideas how you might do that? Yeah, you're totally tired. Okay, so you could check in with the person raising their concerns, ask them how they think the project is going and give them an opportunity to raise any issues in a really open and productive way. As I said, a lot of complaints result from miscommunication and misunderstandings. So check in with the person. Say, hey, I just want to make sure you're really happy with how this project is going. Is there anything that you're not happy with that we can work through now? Ask what their desired outcomes are. So if they say, look, I am really unhappy about this, say, okay, well, what does resolution look like to you? How do you think we can work through this together? Think about whether the person would benefit from talking to a more senior colleague. So there's a number of tips and tools there. I won't go through them all. But my tip is take a step back and survey the entire situation. So this takes us right back to the beginning when I talked about System 2 thinking. Pause, think about everything that's going on, think about where the person is coming from, put yourself in their shoes, and remember how you felt that time that you were dissatisfied with the service that you received from a professional and how you wish your concerns had been dealt with. Adopt the old maxim, treat others as you wish to be treated yourself. And if they do complain, work with them on resolution. Keep a really resolution-focused mind. As I said, this is a whole another subject area. We did develop a toolkit last year to help engineers work through these issues. So recognise when someone's becoming dissatisfied and help work through how you might respond to resolve that. And that's on our website if you ever want to have a look at it, we're under all the complaints information. But there's a few rules. Stay calm. Listen to what the person has to say and try to see things from their perspective. Remain polite and respectful. So remember your ethical obligations. So your ethical obligations apply in respect of how you respond to complaints and concerns as well. Try to keep your emotions out of it and provide information. And don't be defensive or take it personally. Don't blame others. Don't make assumptions without checking facts. Don't argue with the complainant. And don't be dismissive, because it actually takes a huge amount of courage for people to complain. Okay. And if something comes to, if you can't resolve something directly with your client, or your firm can't help you resolve it and it comes to us, trust us, we have a fair and robust process to resolve concerns, and we'll work with you to try and resolve it in the most appropriate and proportional way. And maybe someday you'll come along to a separate presentation I'll do about what that process is. One key theme or message from what I see through complaints is that good communication is the key to working through difficult situations. I've hammered that home a little bit today. It can improve all working relationships and help avoid misunderstandings. And just to wrap up, you're going to face some real practical and ethical dilemmas in your work. That is a given, and the answer won't always be clear to you, and that is okay. If you face a hard decision and you're not sure what to do, ask for help. You're not alone. Think carefully about your obligations, what the code says, your options, what the different scenarios are. Talk through it with a manager or a trusted colleague, or call us at Engineering New Zealand, and keep records of what you do and why. So that's me. Thank you for coming along. I hope that you've got something out of it. Here's my email if you have any follow-up questions. Really happy for anyone to get in touch at any time. And I'm going to pass to Kavita.
Okay, thank you very much for coming along. I also want to just do a couple of thank yous. First of all, thank you very much to the University of Canterbury for hosting us here tonight. I also want to thank in particular the lecturers Dirk Pons, Kim Rutter and David Wareham for encouraging the students to come along, and also Graham Harris and Rob Danza from ARA encouraging the students to come along as well. As Helen said, there's a free webinar that's on our website for ethics as well. There's also our Code of Ethical Conduct on there as well, so do take a look. But thank you very much. Best wishes for the remainder of your studies. Cheers. Good night.